What's up, guys? I'm the quickest math tutor, and today I'm going to be going over the normal model in AP Statistics. So there's 4 easy steps to solving questions that include the normal model. Step 1, you draw a picture. Step 2, you calculate the z-score. Step 3, you write your probability statement. And step 4, you write your conclusion. So here's the equation that you must know for the AP Stats exam. Z equals x, which is a number that you will be getting, minus mu, or the mean, all over sigma, or the standard deviation. So you will be using your calculator. It really depends on what calculator you have. So if you're using a certain calculator, you might have these steps to find normal CDF because you are going to be using that program in your calculator. So first you click menu, then you click stats, then you click distribution, then you click normal CDF, and you're on your way to go. But the calculator that I have right now is a TI-84 Plus, so I will just be hitting second, VARS, and choice 2, which says normal CDF. Okay, so now I will teach you how to do these normal model problems. A more challenging version of a video game was released that made it harder to survive without losing any points. Let the random variable x be the amount of time in seconds that an individual can survive this game. It is known that x follows a normal model with mu equals 15 seconds and a standard deviation of sigma equals 3.75 seconds. What's the probability that an individual can survive in for less than 8 seconds? Okay, so you want to remember step 1, which was to draw a picture. So I'm going to draw the normal model, and it looks like this. So we know that the mean is 15 seconds, so that's going to go right in the middle, 15. And the standard deviation is 3.75, which we will use for our equation. So the first thing you also want to write in every exam, make sure you write this on your tests, and then you're going to just write your mean and your standard deviation. So I'm going to write 15, 3.75. Think of this line right here as a number line. So over here it says 15, so 8 is right before that because 8 is less than 15. I'm going to write the 8 right there. So it's saying the probability that an individual can survive for less than 8 seconds. So I'm going to make a dotted line right over here, and I'm going to shade less than 8. Okay, so this is really important. Drawings are super important for the AP exam. Please try drawing photos because you might get points taken off. Okay, so next you're going to have to plug into your equation. So the equation was z equals x. So x is 8, so I'm going to put 8 on the top, minus mu, which is 15, all over 3.75, which is your standard deviation. And I'm going to just get this on my calculator. Okay, so I got negative 1.867. Okay, you are not done yet. It's not that simple. Once you get the z-score, your z-score is the key to finding the area under the curve. Because you're going to do this on your calculator and you need points during the test to show that you actually know what you're doing, you're going to write P, Z. Now, you have to write either less than or greater than or whatever than 8 seconds. So the question is saying less, so Z is going to be less. And I'm just going to erase the 8. Z is less than negative 1.867. So that was a silly mistake. Don't write this normal number that they just gave you in the question. You have to write what you got for the z-score, and you plug it into this important formula that you must write. So now we're going to do normal CDF. I'm going to go onto my calculator, and I'm going to get the results. You might have a different calculator, but we will still get the same answer. Okay, so on your calculator, it might say the lower bound and the upper bound. Since we're finding the probability that an individual can survive for less than 8 seconds, we're going to make the lower bound infinity, okay? Or you can just keep writing 99999 over and over again. And for the upper value, you're going to write what you got for the z-score because we're finding anything that's less than that number, okay? So your answer is going to be 0.031 or 3%, okay? Doesn't matter how much you round. So now we have to write the conclusion, and this is really important. You must write a conclusion for any and every AP Stats question you come across, okay? This is really important. This is going to make or break your score. Okay, so here's our conclusion. I'm just going to highlight the really important parts. So it says, according to the normal model, a randomly selected individual will survive less than 8 seconds about 3% of the time. So something really important here is you should always start with some context. So always start with according to, and we're talking about the normal model here. So I wrote according to the normal model. So over here, you can write whatever you want. It just depends on the question. So you just write the context. So I'm not really going to highlight that because it's specific to the question you are doing. And will survive less than 8 seconds. So I'm just going to highlight this because you must put the number that they gave you in the question. You must like mention that, or else it won't be like a coherent answer, and you just want to maximize your points. And about 3% of the time. I'm also highlighting this because that is our actual answer. That's what we got right over here. And yeah, next question. So the second question is asking, what is the probability that a randomly selected individual will survive for more than 11 seconds? So it's basically the same steps over again, so except it's asking for more than 11 seconds. So step 1 is to draw the picture, which we already had earlier. Make sure to write this notation right over here. This is really important. And it's saying more than 11 seconds, so 11 is less than 15, so it's going to be around here. And I'm just going to draw the dotted line, and I'm just going to shade more than 11, okay? So I'm going to shade everything that is coming after 11. Okay, now that we have finished drawing the picture, we're going to plug it into our equation to find the z-score first. So z equals x, which is going to be 11, minus the mean, which is 15, over the standard deviation, which is 3.75, and z will equal negative 1.07. Okay, now that you got the z-score, the second part is done. Now you're going to do our probability statements. So I'm just going to write over here P and Z. So it says more, so I'm going to make this greater. And I'm just going to plug in back the z-score that we just got over here. So it's negative 1.07. Great. Now we go into our calculator and we plug this in. Okay, so I got 0.86, or you can just simplify that to 86%. Here's my conclusion. I used the same formula for writing as before, the same format. So according to the normal model, a randomly selected individual will survive more than 11 seconds about 86% of the time. Okay, we can head to the next question. So the next question is asking, what is the probability that a randomly selected individual will survive between 8 and 11 seconds? So basically, this question is not too difficult. Now you just need to make your upper bound the z-score that you got for 11 seconds and your lower bound the z-score you got for 8 seconds. So you just need to draw the picture like we've been doing, and you just have to find or use the same z-score that we got for the previous two questions for 8 and 11. Okay, so if you notice, I only wrote that my lower bound will be z equals negative 1.87, which was our z-score for the 8 seconds, and my upper bound will be z equals negative 1.06, which was the z-score for the 11 seconds. The reason I did not show my work here is because I already showed my work in the parts before. But if this was a separate question by any chance, make sure you show all your work. But we don't have to here because these are in parts. So now that I have my lower and upper bound, I'm going to teach you how to write your probability conclusions. So P, and we're not going to put z yet. We're going to put the lower bound first. So negative 1.87 is less than z is less than negative 1.06. So z is going to be in between those bounds. So now you're going to plug it into your calculator. And you should have 11% as your answer. It's okay if you round it differently as long as we got nearly the same results, okay? Now I'm just going to quickly show you my conclusion and we can move on to the next question, which is a tiny bit different. Okay, here's my conclusion. Notice how similar it is to my other ones because I use the same format, and this always works. So, according to the normal model, a randomly selected individual will survive between 8 and 11 seconds about 11% of the time. Notice how I restated the question right here, and because I provided context, this will get me all the points I need as long as I showed all my work and, again, provided context. Okay, now let's move on to the last question. Okay, so the question says, how long did the lowest 25% of players / individuals survive without losing any points? Okay, so let's take a step back here. Percent is also known as the area under the curve. That's what we use to identify the area under the curve, how we answered the previous questions. So now they're giving us the percent, and they're giving us the area. So using the area or the percent, we're going to use that to find the z-score and thus get our answer. So we're not going to be using norm CDF for these types of questions. We're going to be using inverse norm. Okay? Inverse norm gives us the left side of the curve. Okay? So let's solve this question. Okay, so first we're going to draw our picture. So I'm just going to draw the bell curve. And we know that 15 is our mean and 3.75 is our standard deviation. So this is important. Don't forget, we're going to write our notation. Many people forget this. 15, 3.75. Okay, this is our mean and this is our standard deviation. Okay, so now we're looking for the lowest 25%. So that would be around right over here, 25%. And it's the lower part of the curve. So next what we're going to be doing is we're going to be writing our inverse norm statements, which are going to be more different than our probability statements, okay? So first I'm just going to write inverse norm. This is how you're going to write it. And first we're going to write 0.25, 0, 1. Okay, so if you're learning currently normal models, you don't need to worry about the 0 or 1. You're just going to write that. This is pretty important, so please write that. Don't just write 0.25. And another thing that you need to keep in mind, this is important, if the question asked you for the highest 25%, you do not put 0.25, okay? The inverse norm, it's only going to give you the left side of the bell curve. Inverse norm, if you want to find the highest 25%, you're just going to have to write 0.75 instead, okay? But we're not doing that right now. We're finding the lower 25%, so we're going to do inverse norm 0.25, 0, 1, okay? That's going to be our quote-unquote probability statement, okay? So it depends on your calculator, but once you hit all the steps that I talked about earlier, instead of seeing normal CDF, you should see the inverse norm function. It's going to be like probably right next to it. So I'm just going to go on my TI-84 Plus and I'm just going to solve this on my calculator. When you do your inverse norm on your calculator, the only thing you're really changing is the area, okay? So for the area, I just type in 0.25. Exactly, that's all you write. And you should be getting an answer of negative 0.67 or around that, depending on how you rounded, okay? So negative 0.67, once you get that, you're not done yet because that is your z-score. So we're just going to be solving for x. So negative 0.67 is going to be equal to x minus 15 over 3.75, which is our SD, or standard deviation. So this is our z-score. Here, I'll just write the equation out for you. Z equals x minus mu over sigma. So as you can see, we got our z-score, so we're plugging that back in, and we're plugging our mean back in and our standard deviation, and we're just solving for x. Once you get that, you write your conclusion. So I will just tell you the answer, and I will also show you the conclusion along with the answer. Okay, so after you solve x, you should be getting x equals 12.4875. If you did not get that answer, maybe you should recheck on your algebra, because people might get the statistics right, but they might get the algebra wrong and it messes up your score. Okay, so once you get your answer, you're just going to plug it into your conclusion. As you can see, again, I write the same format for the conclusion, but I just make sure to write the correct context, okay? So it's a little different from my other conclusions because it's asking for something else. So I wrote, according to the normal model, okay, always write that in the beginning. According to the normal model, the lowest 25% of players/individuals survive the game approximately 12.49 seconds or lower, okay? So one thing that I think I should have added into this conclusion is just to add individuals that survive without losing any points, approximately 12.49 seconds or lower, but that's just me. You always want to be safe when it comes to context, okay? So that's it. I hope you enjoyed. Thanks for watching.